What's up, everybody? Welcome to the stream. I think this is the first time I am covering this topic. Well, I'm not going to be covering it. My guest is. So, Mark, why don't you introduce yourself? Tell us a bit about who you are, what you do, all that stuff.
Hi, yeah, I'm not a philosopher by profession. I'm a software developer, but I got really interested in philosophy like 10 years ago or something because I had this idea that I thought was this really good idea, and I thought, wow, I better learn some philosophy to so I learn how to talk about it. But in the course of doing that, I realized it wasn't my idea at all. It was Max Tegmark's idea. This is this idea of the mathematical universe hypothesis. But I guess I got the bug, and I wanted to learn more and argue more. So I started off just arguing on the internet and stuff on Massimo Pigliucci's blog originally. And over time, like I've spent a lot of time arguing on Twitter with people, and when I was living in New Zealand, I started arguing with Philip Goff a lot in particular. And we kind of made friends. We both enjoy a good disagreement and trying to get to the bottom of other points of view. And then I ended up moving to Durham because of my wife's career. So I was able to meet up with Philip in person. And like, as much as I disagree with him about everything philosophically, he was really encouraging and supportive and giving me time and taking me seriously, even though I have no credentials. And so I just recently got into trying to publish philosophy papers and managed to get one published recently. And so that was fun. So like I'm an amateur philosopher, I suppose. I seem to be taking an interest in sort of multiverse themed sort of stuff. Like I have a lot of the same views as you do with regard to philosophy of mind and meta ethics and stuff, but I don't have as much original to say on that. I basically go along with nearly everything you say on that topic, and you say it better than I would. Whereas for some reason, I found I have some original things to say about multiverse sort of stuff, which is the papers I've been writing have been in that area.
All right. So I did put a link to that article in the description. So you got an article. Do you have other articles in the loop, or do you have other things in publication, or is it the one article? What do you have so far?
I've written 5 papers and I've had one published. There's one under review. There's one I think is nearly ready to submit, and there's a couple that are a bit maybe half baked and need a bit more work. But they're all kind of multiverse themed. So the one that was published is on the theme of quantum immortality. Um, the basic gist of that article is that I think a lot of the many worlds people like Sean Carroll and David Papineau and David Wallace are a little bit too quick to dismiss the idea of quantum immortality. So like I have a lot of sympathy with many worlds. I think it's probably the right interpretation of quantum mechanics. We could get into what that is. Probably a lot of your audience already know. But it's just the idea that like Schrodinger's cat is both alive and dead at the same time because the world splits every time there's some quantum measurement. And I think that's probably right. I go along with Sean Carroll, where he says that that's the most kind of parsimonious, simple interpretation. We just have the dynamics of the Schrodinger equation, nothing else, and that sort of by itself implies that the world is splitting all the time. But then you have this idea of quantum immortality. What if you yourself are in Schrodinger's cat's situation? Should you expect to survive the experiment or not? And a lot of the many worlds people are kind of saying no. Like after you split, you're different people. So the fact that one of you is dying is not compensated by the fact that one of you is going to live. Or like David Papineau would say things like that the born rule is the rule that tells you what's going to happen, and there's no motivation to deviate from that and say that actually you're going to survive. So the paper I wrote was just saying, yeah, we can take many words to be true, but I don't think there's. I think these arguments against the idea that you should expect yourself to survive are not very strong. And that's a problem because quantum immortality is not really good news. It's not like, okay, the clearest cases are where we're going to instantly die or survive because you've got like a gun and it's like Russian roulette, but you're measuring spin up or spin down a particle. You're going to die straight away or not. But potentially, like everything is quantum at some level. The decay of DNA is something that can happen or not happen based on quantum fluctuations. So aging is arguably quantum. And so potentially if quantum immortality is right, then we're all subjectively immortal. So there'll be some universe where you don't die. But that's not good news because you'll still see all your loved ones die and everything you love decay and fall apart. And you'll be left alone as some sort of Boltzmann brain enduring the heat death of the universe or something. And that doesn't sound like fun. So I would dearly love there to be a good argument against quantum immortality. It's not something I want to be true, but I just think all the arguments that are out there are a bit half-baked. And so the paper is uh, making the case that they're a bit half-baked and why it's something we should take a bit more seriously.
So, since you endorse the many worlds view, you think we're literally stuck with subjective quantum immortality at present?
Um, yeah, maybe. What I'm mostly arguing is that the arguments against quantum immortality are not very convincing. Um, I I'm kind of engaging in motivated reasoning a little bit in that I don't want it to be true. So I'm hoping there is some good argument against it. Um, but I haven't really thought of one. Like there's a couple of possible get out of jail ideas. Like I think Max Tegmark suggested that maybe there'll always be some branch of the wave function where you survive, but maybe in cases where you're like decrepit and falling apart, maybe consciousness can sort of fade away. And so maybe your nearest, your most likely successors are ones where you're a little bit less conscious. Like some people think consciousness is either on or off and that there's no in between. I'm not one of those people. I think like you can kind of fall asleep and drift away, and consciousness is something that comes in degrees. So I can kind of imagine consciousness tapering away asymptotically to almost nothingness. And that might be not so bad. Another idea is that another idea I've had, I think I haven't seen anywhere else, is that like if you're falling off the Empire State Building and you're about to go splat on the pavement, what is the most likely way you could survive that? Like somewhere in the quantum multiverse, you're going to survive it somehow. So you should expect to survive it in the most likely way. And the most likely way you're going to survive something that's so likely to kill you as that is probably you wake up and it was all a dream. Like there'll be somewhere out in the multiverse someone who has like psychological continuity with you. So I kind of follow a Parfitian view of personal identity where psychological continuity is what matters. Somewhere in the multiverse, there'll be someone who is having a dream that they were falling from this Empire State Building and they have your psychology and you'll wake up and you'll be that person. So like maybe there's some sort of recurrence where you keep repeating your life and waking up and it was, I don't know. But there's some ideas where maybe it's not so terrible to be immortal, but I don't know. I don't know what to think about it. I just know that the arguments against it are too dismissive by half, and they could use a bit more leader.
I can imagine. I have a couple questions about the implications of this or how this might play out. But if you imagine the unusual circumstances where you're immortal, where it's not like, you get to 95 years old and then you just wake up and it was a dream and you're actually 20 and you're healthy, or you're in a radically advanced future civilization where with life extending technology and actually you were just in a VR headset simulating a life, kind of like in Rick and Morty. There's like a lot of scenarios where, okay, well, that might be more likely than you just spontaneously through weird quantum fluctuations happen to live to 150 and be perfectly healthy for no apparent reason under
Exactly.
the
Yeah.
current Earth conditions. Maybe that's less plausible. I don't know. There would have to, in extremis, it would have to be like you just don't age for 1,000 years, you don't age for a million years, and during that time, nothing ever takes you out. Okay, maybe at a certain point, it's more likely you're in a simulation. So I can imagine those scenarios. But let's just say it's ordinary biological like idiosyncrasies. You just stay alive until the sun expands and consumes the Earth, and Andromeda collides with the Milky Way, and you're just floating in space, some kind of weird Boltzmann brain thing. Um, like when I try to extrapolate and think what would that be like, it's easy for me to sort of have a really anthropocentric perspective on that and go, oh, that would be really boring because everyone I know would be dead and it would be really miserable to just watch the Earth get boiled away and is stripped of its atmosphere and all life on it gets destroyed. But at that point, maybe it's not so easy to imagine what that experience would be like. Like I wouldn't have maybe ordinary sense capacities at that point. Maybe my emotion, like I'm not going to have hormones as a Boltzmann brain, I don't think, influencing me. I don't know. Like I don't know exactly what the psychology of a Boltzmann brain would be like, and I can imagine it could be really variable. So maybe at that point, our or the circumstances of our existence, it wouldn't be so miserable. Maybe we'd be really contemplative. Maybe we'd be really good at imagining things, and we would be in a kind of foggy dream state, reliving the past, and it's beautiful and wonderful. I don't know. Maybe it wouldn't be so bad. Is it
Yeah,
possible that what?
that's a little bit like the idea that maybe consciousness fades away, the foggy dream state kind of idea. Yeah, I don't really know what to think about those kinds of cases. They're really difficult to think about because they're so out there. So I'm more comfortable talking about the, like sudden death from like a Schrodinger's cat type or quantum
Mhm.
roulette sort of thought experiment. And that's mostly what I discussed in the paper. Like, what if death is like instant? Um, how should we think about it? Should we expect to survive or not? Um, so like there's two questions I suppose we could ask. So the paper's kind of divided into two. So the first is on the retrospective question, which is suppose you've just survived a quantum suicide thought experiment, or suppose you've survived 100 of them, like against impossible odds. Is that now evidence for you that the many worlds interpretation is true? Are you now going to be a true believer? Oh, many worlds must be true because otherwise I wouldn't survive. And like I think it sort of obviously is, but interestingly, David Papineau published a paper arguing that it wasn't. Um, so I don't know. What would your own take be on that? Like, if you've survived, like, is it evidence for many worlds or not?
Well, it's something I like to tell my students, which is that when scientists test hypotheses, like if you read a paper and they test a hypothesis, what they'll often do is if they get evidence in support of the hypothesis, at the end of the paper, they'll say, hey, we've provided evidence that our view is correct, and that's true. But it's also true that what they've really done is they've recalibrated the probability of like an infinite number of hypotheses, the probability of them being true. The ones most consistent with the data get the biggest boost. The ones least consistent get like their probability declines, and then maybe there's a bunch of stuff along the spectrum in between. And so really what you're doing is you're shifting the probability of all the possible ways that you could look at things, conditional on interpreting the evidence in the way that you are describing. Of course, it's always possible to reinterpret the evidence in a whole bunch of ways. So it's really about shifting all these possibilities. And so when I hear, like you survive a bunch of roulette type situations, would that increase the probability of like the many worlds interpretation? Is that the idea that at that point you go, oh, all right, so many worlds has got to be true?
I
Yeah.
think
So then,
it will do some shifting of the possible. I suppose my point is that David Papineau thinks it doesn't give you evidence of anything, and I don't
see,
think
that's
that's
that. So I again, just so people know, I'm saying again because I already mentioned this to you, but people don't. I don't know much at all about quantum immortality or fine tuning. I don't really deal with because like fine tuning, I typically think of it in the context of like a like philosophy of religion and like I don't know. I just don't really study this stuff very much. But when I look at that, I'm like, all right. So I think yes, that would increase the likelihood that I would think the many worlds interpretation is true. I might also start thinking of things like fate or divine providence or other
oh
sorts of
yeah,
exotic possibilities that I ordinarily would not entertain. They would not be my go-to.
yeah, yeah,
As
yeah,
much as
yeah.
I like to say I'm not a naturalist or a physicalist, I very much have an inclination or bias in that direction where the supernatural is like way on the bottom of my list. But if I survive 50 roulette situations or I, fell off a building and instead of waking up in a simulation, like somehow I just am just fine. I don't know why. I get up, I dust myself off, and I fell off a 50-story building. I'm going to go, all right, well, quantum immortality or religions or something. So is that a
Yeah,
reasonable reaction?
yeah, I think so. Yeah, I like the main thing I'm reacting against in this paper is David Papineau kind of saying, "Well, you don't learn anything. You just have to chalk it up to coincidence." Because, well, he's not saying. Well, maybe he would be sympathetic to the idea that you could appeal to God or providence or something. But he's just saying it doesn't give any boost at all to many worlds because he's saying that if many worlds were true, it doesn't explain why this particular version of me survived. And this is a nice segue into the whole fine tuning thing. It's kind of something we should talk about because it's very much the same argument that I want to get into there. The idea that appealing to like a multiverse where things that appealing to a multiverse doesn't explain like a coincidence like that, because it's still a coincidence. And so, like to David Papineau, it's just as much a coincidence that you survive if many worlds is true as if it isn't, because he thinks that you should judge the probability according to the Born rule either way, and so it makes no difference whether many worlds is true or not. So I kind of sketch out in half the paper why I think that's wrong. Then the other half is addressing the other question about whether you should expect to survive, supposing you believe many worlds is true, because I think they're two different questions. And the second half of the paper then explores that by means of a thought experiment where I do Dan Dennett's thing of like tweaking all the dials on the intuition pump to try and really, because there's a whole load of get out of jail free cards that you can play to just not have to think about it. Like, because maybe it would be crazy to do the Russian roulette experiment because, you know, you'd have bereaved family and all that kind of stuff. Or you could imagine you don't want to have a delayed death from death, like if it's from exposure to radiation or something. Suppose like you're Schrodinger's cat, but the decay happened yesterday and you're going to die 2 weeks from now because of radiation poisoning. Then you're going to have, that really drives against the intuition that you should expect to survive, because you should expect to maybe experience 2 weeks of suffering and then die. And so there's all these other issues that are kind of mixed up in it. And so I'm trying to come up with a thought experiment to just bracket it all that and just think about survival. So that's what the paper is about, basically. But
I don't know how much people that are watching this might need a bit of a background. Should we tell people just generally a bit about? So, I'm familiar enough with there being different interpretations of quantum mechanics, like in many worlds, and the Copenhagen interpretation, and then I don't know, like hidden variable type interpretations. Do you want to maybe give us a bit of background and context to sort of segue into discussing quantum immortality and fine tuning, and I don't even know if people are going to know what fine tuning is and how all of this stuff relates to fine tuning questions.
Yeah, so the different interpretations of quantum mechanics aren't that relevant to the fine tuning issue, but it would shed a little bit of light on the conversation we've been having for the last 17 minutes. So I can retrospectively give a bit of context there. All right. So the basic issue is that the observations we have and the predictions we make from the formalism of quantum mechanics seem to have this property where things can be in more than one state at a time. And this is clearest in the case of elementary particles like electrons or photons or whatever, and particularly in the classic experiment of the double slit experiment. So the best explanation we have for the interference patterns we observe is that, in some sense, the electron or the photon seems to go through two different slits at the same time and interfere with itself somehow. So all the different interpretations of quantum mechanics are attempting to make sense of this. So the mathematics of quantum mechanics is given by the Schrodinger equation, and on its face it seems to show that things can happen in more than one way. And then when we make an observation, all these possibilities collapse and we only observe one thing at a time. And so the different interpretations are trying to make sense of this, like what is collapse? What's happening here? So I'm not very sympathetic to the Copenhagen interpretation, so I'm probably not going to give the best account of it. But to maybe be a bit unfair to it, it's a bit like saying just don't ask what counts as a measurement. Don't ask what counts as collapse. It's just a rule of thumb. You apply these rules when things are not being observed, and you apply these rules when something is observed. And what you do is you apply the Born rule, which is to take the squared amplitude of the wave function, and that gives you a probability, or a number that's interpreted as probability. That tells you what's going to happen, or the probability that something is going to happen. So the Copenhagen interpretation is just saying there's these two ways of thinking about it, and whenever a measurement happens, that's when collapse happens and the Born rule applies. And it doesn't really define exactly what counts as a measurement, which is not very satisfying to a lot of people. The Born rule then, or sorry, the the Bohm interpretation, or Bohmian mechanics, Bohm de Broglie, is another way of looking at things where you have particles and you have the wave function, and they're two different things. So the wave function is guiding particles. So the wave function is kind of going through the two slits in the double slit experiment, and interfering with itself and giving an intensity that will appear at different points on the screen. And that guides the particle as to which path to take, but the particle still takes a definite path. Many worlds then is just saying the particle really does go through all the different paths, and it does interfere with itself until decoherence means that the different effects propagate out through the environment, and at that point it stops it from interfering with itself anymore. But part of what happens as a result of this decoherence is that we can make an observation, and the experimenter can actually see where it's gone. But what's really happened is the experimenter himself now is in two different states at the same time. One has seen the particle go left, and another has seen the particle go right. And so the universe is effectively splitting all the time. But this splitting is really just a description of the overlay on things. Really, all that's happening is that we've got this one universe governed by the Schrodinger equation, which is evolving, and lots of different things are happening inside there, which we could describe or carve up into different worlds if we so choose, with observers, with one observer split into two or many over time. So, like in this view, like basically the world is splitting constantly. We're constantly dividing into multiple successors. And so that raises a lot of questions about how do we think about probability in that context, and how to make sense of personal identity, and questions like quantum immortality and so on. And there's loads of other interpretations as well. But those are, I think, the main ones. There's superdeterminism as well, which is a bit of a weird one. I know Sabine Hossenfelder is a fan of that one. Superdeterminism is the idea that it's basically like the initial conditions back at the Big Bang sort of explain it, that really it is all just particles, but that everything is set up at the since the Big Bang, so that everything is destined to play out in such a way that things just look like there's these interferences, and that things are in more than one place at a time. But really, that's just because of the initial conditions. So, like one of the assumptions of one of the great theorems of quantum mechanics Bell's theorem is that the experimenters can make choices independently and freely about what direction to measure spin in, or what to measure in quantum experiments. And that's one of the assumptions that undergirds the idea that there's no local hidden variables, as there would be if there really were particles in definite locations with definite states. But like the idea of superdeterminism is actually no, you can't make decisions freely or independently. Everything is set up since the Big Bang so that you were destined to make these decisions that would just so happen to give the kind of correlations that we observe. So yeah, that seems a bit bananas to me, to be honest. But that's a view that some people take. So what I like about many worlds is that it seems to me to be the simplest, most parsimonious explanation. It's basically just taking the dynamics we already observe for small particles and just saying there is no threshold or cutoff where things behave differently. Actually, that reminds me, I've left one out. There's the spontaneous collapse interpretations like Roger Penrose has, which kind of says that as systems get big enough, maybe because of gravity or something, they just spontaneously collapse. So there's like objective collapse, where these systems in multiple states just collapse down to one state. So it's not because of an observation or a measurement, it's just because they're big enough that after a while they just collapse. So like a lot of these ideas are introducing additional postulates, like the ones about objective collapse, or the ones about measurements, or the idea that there's a separation between the actual particles and the guiding wave equation in Bohmian mechanics. Whereas many worlds just says that the dynamics at the small scale are the same as the dynamics at the big scale. And I like that because I don't think there's any reason to believe that isn't the case. It kind of reminds me of, was it Wittgenstein that said something about, whether the Earth goes around the sun or vice versa. Well, you say that it seems that the sun goes around the Earth. Well, what would it seem like if it didn't? And it would seem exactly the same. And I think this is what we would observe if many worlds were true. So, like, without any evidence to the contrary, like, I don't think there's good reason to reject it. Um, I think the reasons people do have for rejecting it is that they think it really does violence to our notions of personal identity or probability, this sort of thing. So they think it's sort of incoherent, or that there's something wrong with it for that reason. But I don't buy those objections personally. So I've waffled on a bit there. So if you have anything to
Yeah, it does make me wonder how much, because you had mentioned earlier that you have a degree of motivated reasoning and accepting arguments in a particular direction when it comes to the implications of quantum immortality, which is downstream of the many worlds interpretation. And yet, it may be that some type of motivated reasoning is influencing the rejection of the many worlds interpretation in the first place. And I'm wondering if you have any thoughts on how much, I guess what you could say is motivated reasoning, but more particularly like what people want to be true because they have a preference for those implications being the case, how much that might guide uh, judgments about the likelihood of these different positions. Because, part of the reason I'm curious about that is because my initial question is, why are all these people rejecting quantum immortality in the first place? And I had to wonder, do they not like the way it sounds? Like, sometimes I think people may just reject something because on the face of it, it seems ridiculous. Like that might be about all they could say about it. That seems absurd. And so I guess there's a couple questions. Sorry, I'm like wrapping my questions up in each other. One is the role that you think motivated reasoning might play in adjudicating the different outcomes in these cases, and how much people are depending on their conception of the palatability of the consequences. And then the second is just the degree to which judgments like this sounds absurd, this sounds ridiculous, might be influencing people.
It might, but as you know yourself, it can be a little bit obnoxious to argue against people by psychologically interpreting their reasons for it. So, yeah, I mean, that sounds plausible, but I'm more willing to own up to some motivated reasoning on my own part than by diagnosing it in others. I think that the best case against quantum immortality is the kind of one offered by David Papineau, where he says, like, the born rule is the rule that tells you what's going to happen. You don't have any motivation to deviate from that. Now, I disagree with that, and I explain why in my paper. But I think that's a plausible place to come from. That's not necessarily motivated reasoning. Whereas Sean Carroll's arguments are a little bit. He hasn't published anything on this. He's mentioned it in his book, which, yeah, I think Something Deeply Hidden is where he discusses it. And he's mentioned it on podcasts and stuff, but he hasn't written an academic paper arguing against quantum immortality. So he gets a pass for being a bit vague on it. But his arguments are just you're not compensated for what happens on another branch and stuff like that. So he's just a bit more dismissive of it. But yeah, I think plausibly motivated reasoning has something to do with it. It's not a desirable consequence. It's a bizarre consequence. So, like, I think the many worlds people like to think of themselves as the kind of hard-nosed realists who just accept what the science tells us, and subjective immortality is a truly bizarre consequence. That it feels like the kind of thing that some people might want to be true, and so to them it might feel like if they're hard-nosed, they're not going to be grasping for straws to believe they're going to live forever. Immortality is for the theists and the New Age people, not for the hard-nosed scientific realists. But yeah, I don't want to be attributing psychological reasons to people if they have philosophical arguments to me.
All right. So, do you want to walk us through some of the arguments in the paper, or do you want to move this on to fine tuning? Where do you want to take things?
I think let's move on. I have a blog post on the Substack that goes through the paper. I suppose that would be the best way to get into the arguments. But I think what I'd want to talk about maybe more is fine tuning, where I'm kind of curious just to see what you think if I walk you through the arguments there. if that's all right, because this has been an obsession of mine for the past few years because I've been arguing with Philip Goff about it endlessly. And it's like Philip and I disagree about so many things, but this is the one thing where I think he's just demonstrably wrong, and he should agree with me that he's wrong, even if he doesn't about moral realism or philosophy of mind. But frustratingly, he hasn't given in yet. Although he's had his moments of doubt, but he keeps rallying with new arguments. So anyway, I might go through that if that's all right, Lance.
Let's do it.
Okay, so the fine-tuning problem starts with something that scientists have noted, which is that the constants of the laws of physics, like the speed of light or the mass of the electron or the strength of the charge of the proton, or, whatever. There's all these like magic numbers in our laws of physics, and we don't know where they come from. But they seem to be very delicately balanced to allow life to exist. Now, I'm just going to take that as given. Like, there's controversy about that. Like Sean Carroll in particular has suggested it may not be correct. There's books written on the science, but I'm not talking about the science. I'm more interested in what sort of inferences we can draw from this, if it is the case. So let's just take it as a given that if you do almost anything to the constants of the laws of physics, then life seems to become impossible. So you can kind of do this with computer simulations. You can see that if you tweak this, then at the Big Bang, everything flies apart and no atoms ever form. You just end up with an expanding cloud of like electrons and protons and neutrons. Or you could treat these other parameters, or maybe no elements more complicated than hydrogen or helium form, in which case it's hard to see how you could have life. Or conversely, maybe everything collapses into a black hole. But there does seem to be the case, and I think it's reasonably plausible that this is true, that everything does seem to be very delicately balanced to allow not just life, but complexity of any form to arise in the universe. And that generically, you could just plug arbitrary numbers into the equations of the laws of physics, and you get very simple universes where nothing of any interest ever happens. So let's just take that as a given and see what we can draw from that. So there's one camp, like Philip's camp, who thinks we need to explain it with something like design, that this is evidence for something goddish. And I think that's fair enough, a bit like what you said, but if you survived falling off the Empire State Building, that you might take that to be evidence of providence. But I think there's another explanation, which is that maybe there's just loads of universes out there, and they all have different laws of physics. And there's some reason to think that might be true from physics. Like one of our best explanations of what we observe in the microwave, the cosmological microwave background, is that there's inflation, which is that everything flew apart really fast at the beginning of the universe. And one of the models is eternal inflation, which is the idea that things keep flying apart forever. And occasionally you get these bubbles of what we call space forming. And so this ever eternally inflating background. But the consequence of this is that there would be lots of these bubbles out there. And it's not necessarily the case, but it's quite plausible, especially given all the different ways you can interpret string theory as different compactifications of dimensions, the way different dimensions can be folded up. These could lead to different laws of physics. So it's quite plausible that there's lots and lots of bubble universes out there like ours, which have different laws of physics in them. So there's various reasons to think that maybe there are lots of different universes with different laws of physics. So my inclination is to explain fine-tuning as evidence for a multiverse where the laws of physics are different. And as well, like there's other kinds of multiverses. There's, like I mentioned before, Max Tegmark's idea, which is basically that every mathematically possible universe exists, and we're just in one that can support life. So I actually think that's right, but whatever kind of multiverse we're talking about, I think that that's the best explanation for why fine-tuning seems to be required for life. And you, like by analogy, you can look at the Earth. The Earth is just the right distance from the sun to have water. It's got Jupiter to absorb a lot of the asteroid impacts. It's got a moon as well, which helps protect it. There's all kinds of things you can point at with the way that Earth is set up, which makes it just right for life. And as well, like how did life get started? Like that's might be something that's very unlikely to happen. And how did we get eukaryotes? And maybe that's something that's very unlikely to happen. How did we develop intelligence? Like there might be a lot of these coincidences, and you could look at all of these as evidence for design, or you could just explain it by the fact that there are gajillions of planets out there. And we're necessary, like for beings who are asking these sorts of questions, we're necessarily going to find ourselves on one of these planets. And so I think there's no need to invoke design. But then you get these people, these philosophers coming up and throwing a spanner in the works and saying, well, hold on there now. So this, I think, started with Ian Olding, was it, who came up with the inverse gambler's fallacy. So he said that looking at all this evidence of fine-tuning and concluding, well, there must be lots of universes, is a bit like going into a casino and seeing somebody rolling some improbable sequence of dice and winning big and concluding, oh, well, there must have been loads of people in the casino tonight rolling lots and lots and lots of dice. Because that would explain why somebody succeeded against all odds. And therefore, he thinks, but like that's obviously mistaken, right? Because just because there was loads of people in the casino rolling dice wouldn't explain why when you went into the casino, the first person you saw had this big bet. So they think that's a mistake, and they think it's analogous to what's going on in inferring that there must be a multiverse from fine-tuning. Maybe just to stop there and get your reaction to all this and what seems plausible to you.
I've always been puzzled by fine-tuning because I start wondering what the counterfactual would be as an alternative to like a design hypothesis. So the universe was designed because okay, so we have all this fine-tuning and then we infer, okay, given the fine-tuning, it looks like it was designed. But what would it look like if it wasn't designed? Should we expect there to not be any particular perimeters regulating things? Like, it almost be the reverse to me. Imagine if events happened in the absence of any specific finely tuned conditions, and yet things were actually orderly anyway, in spite of that. So is moment to moment, every moment of my continued existence a miracle? There's not the highly tuned facts about gravity that is keeping the atmosphere from dispersing, that's keeping us from getting gobbled up by black holes, or from particles just dissolving and coming apart at the fundamental seams. It's all just coincidence, because that would be I would take that to be like kind of miraculous, and maybe that would be evidence of design. So what would things look like if things weren't designed? Would they not look like this? Like what else would it be like? Like what would we expect of a universe where we existed but it wasn't designed? And I haven't read enough to know if there's a good answer to that. So it's not really clear to me why, when we look at these allegedly highly tuned perimeters, why we should think that they are tuned in any particular way. So much as we might just think, well, how else would it be? Maybe so. People characterize it almost like there's these dials, like these really big dials, and you have to get all the dials just right for this sort of universe to occur. But I guess I wonder, is it in fact accurate to describe things in those terms? And second, what would it be like if things weren't designed? Would we expect things to be different than what we observe? And I just don't know if there's a good answer to that. Do you have any thoughts on that? Or because those could just be profoundly ill-informed presumptions that I'm making, that are just rooted in ignorance about what fine-tuning people are up to. But maybe I don't know. What do you think?
Yeah. Before I answer that, I just realized, just reflecting on this, that I mixed up two philosophers. I mixed up Ian Hacking and Alan Olding. I think I said Ian Olding. So just to correct that. Sorry about that.
I wouldn't know the difference.
Yeah. So that's like, I think if the universe were not designed, what we would expect is that it would be very simple. Given that if we play with these numbers and run simulations, we see universes where everything collapses or everything falls apart. But what you would not like, maybe if we didn't have all these simulations and had done all this work, we might expect that a non-designed universe might look like this. But when we actually explore what happens if you tweak the numbers at all with simulations and with maths, then we find you don't get any complexity. And so,
Right, but let me ask about
yeah,
that. But if like, okay, so if we tweak the perimeters conditional on the outcome of those perimeters being changed, given what we know about their impact in this universe, I can understand why, okay, well, then particles wouldn't form, or it would just be all hydrogen, or whatever it would be. But why couldn't the implications of the laws or parameters themselves just correlate with any possible state of affairs in principle? Like, why couldn't there be a universe where you change the parameters and actually it's identical to this, or you change the parameters and it's just the universe is full of unicorns? Like, uh, it looks like we're conditioning our expectations about what the differences would be on an association between the parameters in this universe and the outcome that they have in this universe, when the very outcomes themselves are things that it seems to me like in principle you should be able to tweak. Like, in principle, a god could just say, look, the speed of light is going to be what it is, and there's no perimeter. I just will it, and it is, and there's no parameters that are needed. And so it seems to me like, at least in principle, um, any parameters are consistent with any possible state of affairs, because a sufficiently powerful being could just decide that they are.
yeah, if you want to break free from naturalism and assume theism, I suppose the problem arises under sort of naturalistic assumptions in the first place. And I mean, naturalistic assumptions are compatible with some sort of theism, because you could imagine that God set everything up to behave in accordance with various rules. Um, but yeah, the problem arises because we're assuming that everything supervenes on laws of physics. And so the laws of physics are what say what happens, not a divine will. And under those assumptions, if you mess around with the parameters, then almost anything you do to them seems to remove complexity. That's the problem. So it's not so much the existence of the parameters or the existence of order. That's the problem. The problem is that the parameters seem to be very, very, very carefully balanced on this. They're teetering on this the edge of a precipice, or on a spike in this landscape of simplicity and bore and monotony. And they're on this tiny little island of interest and complexity. And it's weird that if there's one universe, that is the universe that happens to exist, because almost all possible universes are boring and monotonous. So that's the problem. Like, under the naturalistic assumptions. Does that help to answer your question or not?
It does, but I still feel myself a little unsatisfied with those kinds of responses, because they seem to still be predicated on assumptions made on the basis of the association between the perimeters and their impact in this particular world. And is it somehow anti-natural to think that the laws could differ and then there could just be different outcomes in a different universe? Why would we think that, like, that the like physical, like, the, I guess you could say, like, the nomological features of this universe, changes to the perimeters would result in predictable outcomes in alternative possible universes? So we imagine another universe, we tweak some of the perimeters, we run a simulation. Oh, particles never form. It's just, I don't know, plasma in the void or whatever. I don't know exactly what it would look like. But how, like, why are we changing? We're tweaking the perimeters and then saying conditional on the perimeters and the association between those perimeters and what they would do in our universe, you get these different outcomes. But why aren't the associations themselves something that could be broken and reconfigured and, like, perimeterized and treated as their own sort of mobile possibilities, that those associations themselves could change? And you're suggesting that there would be something involved in rejecting naturalism about this, but maybe I just don't understand naturalism well enough to know why that should be the case.
Well, like there's different interpretations of what naturalism might mean, and it's not something just widely agreed on. But like I'm sort of taking naturalism to be the assumption that there's laws of physics and they're expressible mathematically, and that everything that we observe that happens kind of supervenes on those laws. There's no like divine will interfering and directing things to happen, unless perhaps you could have a mathematical description of God's mind and how His will operates. If you could make a rigorous, precise mathematical description of such a thing, maybe that would be compatible with naturalism. So, like, I'm thinking the laws of physics are a mathematical object. We can, in principle, simulate them on a computer, and we can play around with alternative laws of physics on a computer. And the connection between the parameters and what they do is like part of that model. It's just so if you're saying if I could maybe interpret your suggestion as saying like why do we have this kind of structure with these sorts of numbers at all? We could have completely different structures that are not like this at all. You don't have to just confine yourself to tweaking the numbers. You could completely rewrite the laws of physics in other ways. Like you could take Schrodinger's equation and change it around and change a minus to a plus, or do all kinds of different things, or other than just changing the numbers. Is that sort of compatible with what you're suggesting, or is that a difficult one?
Yeah. What I'm suggesting is that it seems to me at least possible in principle that any set of constants would be consistent with any possible state of affairs. That you could just not only so in other words that they're not bound together such that a given set of constants entail a given set of physical properties, but that the constants themselves could just be associated with any set of properties. Now, if there's some like I have a friend who's really into like the Tegmarkian conception of things in this mathematical universe idea, and they kind of consider themselves some kind of Platonist. And maybe on such a view, that would just be nonsensical if, for certain reasons. But should we be presupposing a view like that when we're making like empirical observations about the world? It seems like there is a potential importation of metaphysical presuppositions that I might not be on board with, or that I might go, yeah, I think provisional on those being right. Maybe they're the most plausible. This is how things are. But is it possible that they're not right? And that actually things could be radically different than what we're inclined to suppose? And if so, could that just break down fine tuning like from behind, I guess you could say?
First of all, I see in the chat there some people are complaining that they can't hear me very well or something. Are you hearing me okay, or is there something wrong?
I am hearing you okay. One thing that might be happening is I don't know if you're leaning forward or back, but sometimes you're a little louder and clearer, and then sometimes it's a little
Yeah.
softer. So there's a bit of inconsistency.
Is it this
I don't
head?
know.
Is it this mic? Is it this mic or is it either?
I don't know. I often have to rely on my audience. So
Do you
I have
mind
my
hitting?
mic is
Do
on a
you mind
stand.
hitting there?
So
Maybe I'll just try to see if I can. Oh yeah, I think I'm on the wrong microphone. Sorry. Uh,
now I'm not
Uh,
hearing you.
Better?
Oh my God. Yes. Okay. Say some more things.
Yeah, I'm saying different things, but now my audio has gone to
Yes.
pieces. Hang on, let me choose a different option there. Yeah, for some reason I can hear you much less now, but yeah, we can try that anyway. You can hear me better now, yeah.
You sound way better to me. Yeah.
Okay. Oh, but you sound way worse to me. But anyway, we can go with this.
Oh well.
Sorry about that, guys. I had the wrong mic selected. All right, so you were suggesting, yeah. So I suppose, could you make your suggestion a bit more concrete? Because I am inclined to think of things in the sort of Tegmark sort of way, as I mentioned. Oh, volume is better, but quality is worse. But anyway, most people seem to prefer it, so we'll go with it. I am inclined to think of things like Tegmark does, so I might be just seeing things in a preconceived way or making assumptions I don't realize I'm making. But I'm having a hard time getting my head around your suggestion. So could you make it more concrete or give an example?
Sure. Can you give maybe it would help if you give an example of one of the like fine-tuned parameters and why, if it were changed, things would be different.
Yeah, well, now we're getting into the physics, and I'm not an expert on that, but like I
Fair
can
enough.
like hypothetically bullshit about something that might be an example of the kind of thing we're talking about. So like we can imagine that if the mass of like protons and neutrons were greater, then instead of stars forming, they might collapse into black holes, something like that. So like from my point of view, like once you understand the science, then this is something you can just put into a simulation, and you can put in all the parameters we measure into the simulation, and you can see that we get behavior like we see in our universe. And then but then you can change the parameters, and you can see that you get black holes and stuff instead. So, like your suggestion is, what if we change the parameters, but we didn't get black holes? But like,
Yeah.
what plays out? Yeah, go ahead.
Let me try to put it in these terms. So if I'm thinking about this universe, when it's interesting when I took a logic in grad school, because I took logic as an undergrad and then I took it again in grad school. We used this like a little simulated simplified universe, which just had basic objects in it. It had like cubes, spheres, pyramids, that sort of thing. And then a lot of what we did with the logic was visualized in the relationships between the objects in this hyper simplified universe. And so you could have rules in like the code for that universe. If X, then Y. If A, then B. And so you could imagine that universe, and you could say, okay, well, scale that up. Now we're in a universe where it has rules like that. If you do X, then Y occurs. And then we could start imagining, okay, well, if you do X, Y occurs, and it happens to be that X is set to a particular perimeter where Y at a particular perimeter occurs. That's very fortunate, because if you changed X, we would have a different output for Y. But that seems to be like what we're doing is we're saying, okay, X has a range of possible numeric values, and then we know, conditional on the rules of our universe, that these values are associated with these values. You could create like a table of possible value relationships. It'd almost be like there's an intrinsic correlation in our universe, like an intrinsic equation that describes the relationship between the two variables as they happen to be. And so you could push the numbers around. So you could have like 3x equals y or something. It's like, okay, so any increase in x is like there's an associated increase in y, and that's just the way it is in our universe. Now we can imagine plugging in different values for x and y and seeing what the differences would be. But that seems to be presupposing that any possible universe would have to be following that equation. But why couldn't the equations themselves change so that in some other universe it's 2x equals y, or x equals y, or 40,000 x equals y, such that now the tweaks in the parameters would have completely different outcomes? It seems like people are assuming we can change one thing, which is the numbers we plug into the variables, but we can't change the equations that describe the universe in the first place. So it seems like one thing is held rigid and one thing isn't. That's what it seems like to me, but I don't know enough about this to know whether that is going on.
No, yeah, that's fair enough. And yeah, so I think your thought is more or less the same as what I expressed. Like, why do we have the structure of the equations? Why are they fixed, and why don't we play around with the equations and completely change the form of them rather than just changing the values? And I think the answer to that is we don't really know how to reason about that. Like, if there's arbitrary numbers in the equations, then you can kind of imagine tweaking those numbers and making them different. And like, they're not parameters that like fall out of any like any theorizing. There's no theoretical reason for those values. They seem completely arbitrary. Whereas a lot of the equations, like, they seem to make more sense, or there seems to be some sort of justification for them. Like, for example, like a very trivial example is the kind of inverse square law about how gravity falls off with distance or electric charge or anything like that. That's a consequence of the fact that we're in three-dimensional space, and so the surface as grows is a 2D surface. So that's why it's the square law. But that's a very trivial example. I'm not a physicist, so I can't talk too much about that sort of stuff. But I would agree with you in that there's no reason we should accept the structure of the laws we have as fixed, and we should maybe be asking why these laws and why not other laws, the way we ask why these constants and not other constants. But I think the answer is we just don't know how to reason about that. You can kind of imagine drawing some sort of probability distribution over your credence that a value would have some value, but like that's a distribution over kind of real numbers. So you can kind of imagine drawing a nice normal distribution or something like that. Whereas if your space of possibilities, like all the possible physical laws there could have been, just more difficult to reason about. So we might well have a fine-tuning problem with the actual structure of the physical laws, but like we don't know how to simulate changes. It's not as easy as playing with the numbers. So like it's not as striking that there's a fine-tuning problem in that case, because you can just literally change the value of the charge of the electron or whatever and see that things fall apart. Whereas changing the structure itself is more difficult to play with. But like I agree with you, and that's part of why I think not only is fine-tuning an argument for some sort of multiverse, like the kind of multiverse we get from internal inflation, where maybe just the constants are changing, but also I think it's evidence for Max Tegmark's sort of multiverse, where every possible physical structure is realized. And in that case, we have an explanation for where the physical structure itself comes from, and it's just that all of them are realized, and only the ones that can support life are ones where we might find ourselves. So in that case, it's not so surprising that the physical structure we find ourselves in can support life. But the thing that really exercises me is the inverse gambler's fallacy charge, which I like. This is kind of what I wanted to get your reaction to. Like, does that seem like a reasonable suggestion to you, that if we're explaining it by appeal to a multiverse, then that's like going in and watching somebody win improbably and concluding that lots of people must have been playing? Like, just like we can go into the arguments back and forth in this, but like, how does that strike you? Is that a reasonable move or not to make?
What can you just like lay it out for me and like refresh me on what's, because I don't know. Can you just lay it out for me and I see my
I'll lay it out.
reaction?
Sorry. Yeah.
I need it like in my working memory.
Yeah. Sorry about that. Yeah. Okay.
No, it's all good.
Okay. So you get the multiverse case. Like, we've seen fine tuning, and I think that's explanation for our multiverse. You get my logic there, right?
Yeah.
Or yeah. So from the other camp, they're saying this is like, you go into a casino, you see somebody winning an improbable prize by like rolling 10 sixes in a row or something, and then you conclude, whoa, loads of people must have been playing tonight for something so unexpected to happen. So they think you've seen something unexpected happening, you're explaining it by saying there's loads of other instances of this happening that we haven't observed, and they think that and so like you're explaining what you've observed by appealing to lots of, and they're saying that obviously that doesn't work, because it doesn't explain why you happen to watch this particular instance the second you walked into the casino. It's not more likely that you would observe such a thing if loads of people had been playing tonight than if only one person was playing. So they think that's the kind of mistake that I'm making by thinking that there's a multiverse. I've lost people. I'm maybe not very good at explaining it. Are you getting it, Lance?
Yeah,
maybe.
I'm not sure that I am.
Okay.
And this might be leaning too much into a literal interpretation of the scenario being described. But at least one difference is that when I'm in this universe, I'm observing things from the point of view of being in the universe, whereas the scenario you described is more a scenario like where I'm outside of it and then I'm observing an instance of it. So, if I walked into a room and you showed me a universe with all these great attributes, and then I go, wow, there must have been lots of other universes that were tried out to get here to get this one. That maybe that seems weird, but I don't know if I'm just having an overly literal interpretation of the of what the fallacy is supposed to be, and I'm just not grokking it on an intuitive level. I'm guessing that's what's going on. That I just have, I'm not getting it, and I have too literal of an interpretation.
Yeah, well, like, first of all, like I'm trying to describe an argument from someone I disagree with, and maybe I'm not doing it justice, but also they're describing what's supposed to be a fallacy in the first case. So this is not supposed to make sense. This is supposed to be nonsense. So you go into a casino, you see somebody winning big, and you think that this is evidence that loads of people have been in the casino. So is the first, like, you go in, the first game you see something really improbable happening. is that evidence that lots of games have been played or not?
I don't have any inclination to judge one way or another about that.
Really? Well,
Yeah.
what you're supposed to conclude is that this is not evidence for lots of games haven't been played. And I think that's correct. So the
Okay.
question is whether it's analogous to the multiverse or not. I don't think it is. And they think it is. So it's supposed to be intuitive that if you go in and you see somebody winning big, that you can't conclude anything about how many games have been played. Because
Yeah, but keep in mind, I don't have intuitions apparently. So
oh yeah, sorry. Yeah. Well, like, okay, if I talk about intuitions, keep in mind, I'm not assuming that intuitions
that was
are reliable.
a complete joke.
Yeah.
I actually didn't have a strong reaction here, but that's probably just due to me being ignorant or not thinking very clearly about the matter. So,
Okay.
if someone was to say, "Oh, you were just stupid or inattentive," I'll take that.
Okay.
But yeah, I didn't have a strong reaction to that. I
Okay.
guess I don't really have well calibrated like probability intuitions. Maybe I don't know.
Yeah. But I suppose if somebody was to say, "Oh, I've observed something really improbable when I just walked into the casino," that must mean that there's loads of games happening tonight, loads of people in the casino.
Well,
The idea,
let me give a
yeah,
comparison where I don't think it would be analogous, but I would make that inference. So I
yeah,
walk into a skateboard park and I see a person do an amazing trick. I actually think I would go, people must have been trying all day long to be pulling off a trick. It would seem a little odd for it to just be I walk in and the person happens to do it then. Um, among other things, I would assume this person has practiced a lot. They've tried to do the trick many times before. Uh, Given that they're doing it now, I know enough about how humans operate that they probably failed many times before they succeeded. But that's a whole bunch of stuff that's contingent on my knowledge of like human development and how people don't tend to succeed at difficult things unless they do easier things first. Or so there's a whole bunch
yeah,
of contingent things bound up in the inference I would make in that circumstance. And
yeah,
then if you take the gambling case, I don't know. Like I start thinking of all the specifics of that and the contextual factors of that. And it's challenging for me, given that maybe. So here's what I think is going on with my psychology here. I think I lack enough background and context about the relevant positions and the stakes of those positions and the implications of those positions to situate the relevance of the thought experiment in the context of that in order to be able to elicit a sort of informed judgment about the matter. I don't know if that sort of scenario you describe is one for which I could have some sort of immediate reaction absent that kind of context. So maybe it's just the sort of thing that requires a certain degree of background and contextualization for me to respond appropriately to it.
yeah. Well, first of all, I'd say there is a difference with your skateboarding example, which is that if you think about how your explanation is actually working, it's quite different from
Right.
the gambling or the multiverse case, because what you're actually positing is that this person has skill, and they have skill as a result of doing it many times. But what you're saying is that it's not so improbable that this person would pull off this amazing stunt, and the reason it's not improbable is because they've worked hard at it and they've developed the skills. Whereas the gambling case is it's supposed to be completely random. So like you're not explaining it by saying actually it's not improbable that this person would win. You're like the reason I think it's correct to say you shouldn't infer that there's lots of games is that even if there had been like millions of times this game has been played tonight in this casino, none of that would explain why the first game you witnessed was the one that was successful. Like that doesn't explain that at all. But okay, here's another version of the casino case, which I think is more analogous to the multiverse case. Like suppose you're outside the casino and you're told you'll only be brought into the casino if somebody wins big. And then somebody wins big and you're brought in and you meet them. So now do you have evidence that there's lots of people in the casino playing? And I think you do, because if there's loads and loads of people in the casino playing, it's likely that somebody would win big and that you would be brought in. So you need to look at like the structure of how you came to observe the thing. Is it independent of the win, or is it dependent on the win? So if it's independent of the win, then there's no particular reason you should think that, like if you were going to watch the game anyway, there's no reason to think the game should be successful And so like nothing is explained by the fact that lots of people were playing. But if you're only going to observe anything if there's lots of people playing, then it is evidence for lots of people playing, because really what you need to explain is why somebody won. It's a bit like if we're together in person and I throw some amazing trick shot of the ball bouncing all over the place and then it lands in a cup or something, you have no explanation other than, wow, that was a freak occurrence, or like I'm incredibly skillful or something. But if you watch that on YouTube, well, if we forget the idea that it's that it might be like digital effects or something, then you can think, hey, the only reason this is on YouTube in the first place is because it was an amazing trick shot that was pulled off. And so maybe there was loads and loads of examples I didn't see. And so maybe that might be evidence for loads of attempts that you didn't see. So this kind of causal dependence matters.
Yeah, that makes sense. And the scenario about the person walking out, I started thinking of it in like dice rolling terms specifically, where if you told me there's a bunch of people rolling million-sided die and I can't leave until somebody has rolled a million, and then within 5 minutes somebody comes out and they're like, yep, I rolled a million. I like at that point I go, quite a bit of people must have been rolling die, because otherwise I would have been waiting out here for a very, very long time for that to happen.
Exactly, yeah.
I do have that reaction. I don't know if that's like the correct reaction, but in that case, at least, I do have some kind of reaction.
Yeah, I think everyone agrees that that's the right reaction. Like everyone agrees about what the correct answers are in the casino case. The difference is, the disagreement is in what's analogous to the multiverse case. So, or the fine-tuning case. So, like basically, the thought from these people, like Philip Goff, is that if there's a vast multiverse with all kinds of different laws of physics and different constants, that explains why some universe is perfect for life. It doesn't explain why this particular universe is perfect for life. So they think that we're making a mistake if we infer that there's a multiverse, because we're throwing away some of our evidence. Our evidence is actually this universe is fine-tuned, and we're throwing that evidence away and coarse graining it and saying that our evidence is some universe is fine-tuned. And they think that's a mistake we're making, that we're not respecting all the evidence we have. Roger White called it the requirement of total evidence, or the total evidence requirement. That it's a principle he's proposing, to say that it's not legitimate to throw some of the evidence away just because it suits your purposes, or you have to take account of all the evidence. And he says that if we do that in the case of fine-tuning, then we cannot infer that there's a multiverse, because it doesn't explain this universe being fine-tuned. So I wonder what you make of that.
I just don't have enough of a background to know how to assess that. So I'd have to ask you.
Yeah.
Well, presumably you don't accept that. And so then, like, I guess a few questions would follow. Do you think that you're throwing out evidence, so to speak, but that it's okay? Or do you think you're not doing that in the first place? How do you respond to this?
Yeah, well, there's been a long back and forth in the literature with people trying to make sense of this situation. Like what's fascinating about it is that it seems like a problem that we should be able to answer, and there's just no agreement on how to reason about it. So one approach that has been tried is to suggest that maybe Roger White's total evidence requirement is not valid. So people have tried to suggest thought experiments where accounting for all the evidence seems to give the wrong conclusions, and therefore maybe it's better to throw the evidence away that it's this universe and just go with some universe. But then other people like Paul Draper have replied and done maths and shown that if you account for all the evidence very carefully, then you can get the right answer in these thought experiments by going with this universe rather than some universe as well. So I think Quentin Rion wrote one of the most convincing papers on this. He got it published in Nous there, or is it Nous? I don't know how to pronounce it. I only read it. Like last year, or I think it was last year. And it's a very technical paper, and it's not very sort of intuitive, or it's kind of difficult. It's hard going because there's a lot of different considerations, but I think he kind of gets it right. And as a result of this and some other thinking I've been doing on it, my reaction now is that Roger White's principle is correct, that we should account for all the evidence. But actually, it's the kind of people who reject the multiverse explanation who are throwing evidence away, because they're kind of ignoring that causal dependence kind of stuff that I was talking about. They're not taking account of the fact that we're not just like randomly observing this universe. We didn't just walk into a casino and arbitrarily choose a universe to look at in the casino universe. We instead arose here as a consequence of fine tuning, and we couldn't have observed a universe that wasn't fine tuned. And this is something they need to model when they're thinking about the probabilities, and they're failing to model it, and so they're effectively throwing evidence away. So that's where I kind of land on it. But I mean, there's a lot more to say on it, obviously. But yeah, I guess if you just don't have any feeling about it, then it's I suppose it's difficult to know what to do. But like, does the multiverse explanation seem reasonable to you, or not? Like,
it has, given what little I know. So, you know, what I recall with the narrative I saw, I actually first encountered really forceful argumentation for many worlds in like Less Wrong in the rationality community. Basically presenting this narrative that the Copenhagen interpretation kind of gained a foothold for reasons that remain mysterious to me, or maybe I just forgot, but it became the sort of fashionable interpretation and reigned supreme as the standard interpretation. And you know, I have a bias against mainstream views, and I don't like dogmatic positions, and I worry about, even in the sciences, so like sociological forces leading to in the entrenchment of particular paradigms, whether or not they stand or fall given the evidence. Like, in other words, they proliferate for reasons unrelated to the merits of the position. And when I looked at that, and then I looked at some of the arguments for like many worlds being more parsimonious, that did appeal to me. And so there have been points in my life where I'd say, yeah, I kind of just buy into the many worlds thing. But I've always had a soft spot for like Bohm type interpretations. But I don't know enough quantum mechanics to know a damn thing about the relative viability of any of these. I don't know enough philosophy of physics. I don't know. So I'm just a total ignoramus when it comes to these topics. And the only thing I could go on is rather rudimentary first principles and what you could describe as intuitions or gut reactions to things. But I have conditioned myself to be so averse towards taking a stance on and only this has only increased over time on the basis of like truth tingle feelings, like, oh, that feels right. That I find myself in a chronic state of almost total indifference or agnosticism about almost anything outside an area that I'm knowledgeable about, to the point where I think that I've probably overcorrected and become too cautious. I mean, people may notice that I talk about like 3 topics, and when I speak outside of those topics, I'm hesitant. But part of that is because I'm not super well informed, and I could bullshit. You know, I could
yeah,
present myself as more knowledgeable than I am by taking firmer stances than I do, maybe with some caveats and qualifications, but still speaking in a firm tone and sounding really confident. I could bullshit my way through looking like I have a strong stance on a wide range of issues, but I don't see the value of doing that. There are people that do read widely enough that they probably do have well-informed positions on things, but I kind of stuck myself down this relatively narrow path of reading a lot of the same stuff. So I've read just a bunch of psychology papers on meta ethics and some other stuff on meta ethics, and then a bunch of stuff on like methods. Like I like to read papers on survey validation. So like I just went down a different path than having the kind of broad generalist knowledge of metaphysics and epistemology that would allow a lot of people in contemporary analytic philosophy to say something substantive about these topics. So if anything, my metaphysical intuition, I guess if you want to put it in those terms, has atrophied over the years. And at this point, I just don't really have a good way of addressing these things. Maybe that makes it difficult for you to talk through these things with me, because at junctures you may want to elicit a reaction from me, and I'm kind of like, I don't know. On the other hand, I might say not being guided in that way does allow me to a certain extent to stand outside of a dialectic in which people have stakes or a dog in the fight for a particular point of view. And when I look at this stuff, I find myself actually less inclined to have a dog in the fight than I used to. And this has generalized. So, for instance, I used to be a utilitarian, and now I kind of tongue in cheek, I call myself a retired utilitarian, as if that's something you could retire from. Uh, I just found over time, why was I so invested in thinking that the right thing to do is to maximize utility? I look at my behavior. Am I maximizing utility by having this conversation or drinking this tea? Did I do the calculations in the store to find out if that's the right thing to do? And of course, I'm caricaturing it because I don't take utilitarianism to be a decision theory, but it doesn't even seem like I'm implicitly trying to maximize utility. And so, it could be this implicit cognitive dissonance, but it wasn't that. It was more reflecting, is that some like weird ideal that sounds intellectually respectable but isn't a reflection of what I actually care about?
Mm-hmm.
Yeah, I think so. And so I abandoned the view on the grounds that when if it comes down to what would I really do if I could push a button and make myself be a utilitarian and like actually try to maximize utility, and like what would I just stop caring about my I didn't think this at the time because now I have a daughter, but uh, thinking about pushing the button now, and I don't care about my daughter's welfare more than the welfare of random children. No bullshit. I'm not going to do that. I'm not going to push that button. I'm not a utilitarian. And so that's the same thing in these cases. So there was a time when, for at least partially ideological reasons, I would go, yeah, many worlds, stick it to the dogmatic mainstream view, and I might even wave a bit of a flag for like the Bohm interpretation, just on the grounds that uh, I don't like the way that philosophers dunk on determinism so much. Uh, and I also don't like the way that they try to circumvent the implications of determinism uh, for the purposes of having compatibilism is the kind of free will worth wanting. Something to me just strikes me as excessively conciliatory about that. I really think that people should be fairly hard nosed. And if determinism is true, some of what people are drawn to has got to go. And I feel the same way in this case, where I have an inclination to say, uh, yeah, many worlds, or like a Bohm interpretation, uh, those seem like the views that people, I think, all things considered, would be less drawn towards for bad reasons, I guess you could say, than the Copenhagen interpretation, independent of the quality of the arguments for them. In other words, one is the fashionable mainstream view, and that automatically gives me a certain degree of contempt for it. But having reflected on all of that, now I realize that the reasons I'm that are guiding me towards taking one position over another are things like which is the edgier position, or which is the less mainstream, or which is the more anti-dogmatic position. And those aren't good reasons for endorsing things. So I've kind of withdrawn and now sit in a position of thinking I would need to know a lot more to weigh in on the topic, and it's unlikely I will. So I'll sit and stew in my agnosticism. And maybe that's not very satisfying to other people, but that's where I think I need to be. Does that make sense?
Yeah, no, it does. But I suppose I see Philip has joined the chat there. Hi, Philip. So I hope I haven't. I've tried to explain your position a little bit already. I hope I haven't done it too much violence. Um, so I guess though, I suppose with regard to this debate between Philip and I feel like it's not something you necessarily need to be hugely knowledgeable about. In that, I think the core of the disagreement is quite simple, and it doesn't require knowing the physics. I suppose maybe it requires knowing some of the positions that people have expressed back and forth over the years. But like, to me, the basic idea here is unfortunately a very intuitive one. Um, and it kind of jumps out to me that a multiverse would be a good explanation, and just as true, it jumps out to Philip that it wouldn't. And it's I just find it very perplexing, or like not frustrating, but like it's a constant source of fascination to me. This is one of the disagreements that I enjoy exploring and trying to get to the bottom of. Like, for example, I don't feel any need to explain why Earth is perfect for life. I'm not sort of motivated to look for design in that everything in Earth on Earth is so perfect for life. So I think that is well explained by the fact that there's loads of planets out there. That is just very satisfying to me as an explanation for why Earth should be so perfect. And I would imagine it's pretty satisfying to most people. Again, I might be asking you about your intuitions here, so maybe you don't have a reaction, but like, do you think that the fact that there's lots and lots of planets is a good explanation for why Earth is just right?
I don't know. I mean, maybe I don't. I worry that when I'm being asked that question, maybe you would be expecting this of me, but I've had so many conversations where what I'm expected to do is have this almost, to me, magical sense of the truth. Like, I'm drawn to this particular answer over that particular answer. And I just feel myself just deeply ambivalent about that. So, yeah. So if I take a step back and I go, all right, well, we're alive here. I've been actually watching a lot of videos assessing the potentiality for life on various exoplanets, and often you'll see people get quite excited. So they'll say things like, "Oh, well, this planet is in the habitable zone around its star, and it's a approximately Earth-sized planet with a mass 4 times greater than the Earth, so it's probably a rocky world. So hey, it's in the habitable zone. There could be liquid water on the planet, possibility for life." And then you look into the details, and it turns out it's a planet orbiting super close, like way inside the orbit that Mercury has around our sun as a distance, because it's a red dwarf. So to get the equivalent amount of radiation, it would have to be very, very close. Okay, well, red dwarfs exist for a very long time, and when you're that close and there's a lot of solar flares, there's a good chance that whatever atmosphere it might have had has been stripped away a long time ago or will eventually be. So is it a good candidate for life? Probably not. It's getting bombarded with nonstop radiation. We don't have any particularly good reason to think that it has like a strong magnetosphere. Like there's just no particularly good reason to think that, like, I don't know which planet this was, Kepler or something. Like, is it actually a good candidate for life? So when you look at that, the more and more we look at the universe, it might look like Earth is special. But I don't think that we actually know, because we have all these observation effects where, given the current ways in which we detect extrasolar planets, we tend to, like, the first methods of seeing like dimming. There's like a Doppler type detection method. So a lot of the ways in which we would detect planets is they'd have to be fairly large. They'd have to be fairly close to the star. So we happen to be observing planets that are probably not like our solar system. So is our solar system unusual? It looks like probably it actually is. The more we find out, the more it looks like, yeah, it's a bit unusual, because we have stuff like Jupiter, which seems to have helped out Earth. There's other sorts of things that seem like we have all these serendipitous alignment to make our solar system unusual, but it's so contingent on the empirical details, and they're in a constant state of flux, that makes me somewhat cautious. And so when I'm told, hey, the empirical details don't matter too much, I mean, look at the approach that I take to meta ethics. It's like I went and literally got a psychology degree to do meta ethics. So my approach to a lot of things is to just really, really, really lean into the empiricism. And part of it, you could say, is that I have an expectation that as our empirical understanding of the universe gets better and better and better, I think it will bring into sharper resolution a lot of the judgments that we're currently making on the basis of intuition or probability assessments contingent on what we know. Some of those I think will just dissolve. And so I'm not sure that empirical details are not so relevant here, or that we shouldn't be concerned about them. And because I'm not that well informed on fine tuning issues, that makes me more cautious. In the case of exoplanets, I happen to be interested in that and know at least a little bit, marginally more than that. I get pop science videos on YouTube. So I'm not going to take that to make me some sort of astrophysics specialist or something like that. I'm very, very, very far from that. So yeah, I do think empirical stuff. The too long didn't read version is empirical stuff does matter to me. It matters a whole lot, and it really makes me cautious because I know I don't know the empirics on a lot of stuff.
But I think the way I look at it is you can kind of bracket that by, you can ask what would be the case. How should we reason if the empirical stuff turned out this way? How should we reason if the empirical stuff turned out another way? And so, like, you can ask those kinds of questions without actually knowing how the empirical stuff turns out. Like, it could turn out that there's life, life is abundant, and it could turn out that life is not. So if it turns out that life is not abundant, and Earth really is very, very special, should we be surprised by that? Should we be saying, well, this is evidence that God has designed Earth for us? Or
Yeah, fair enough.
or
And my answer to that would be no. I'm not surprised. Like wherever
yeah,
we would happen to be, we would be the ones asking the question. So it doesn't strike me as surprising.
yeah, and I think I agree with you there. Like, but on the other hand, if Earth were the only planet, or if we couldn't see other planets, or if the universe appeared to be devoid of other planets apart from Earth, then it might be a little bit surprising that everything was set up just perfectly for life on
Yeah,
Earth.
let me ask you this. Imagine we had, obviously we don't, but imagine we had some sort of super telescope that gave us a perfect scan of the entire observable universe, and we could like do spectroscopy on all of the planets out there, and even like all the moons, all the stars, all the intergalactic structures that could harbor really unusual forms of life or whatever. And we find absolutely nothing. And so we're now very confident that only Earth has life on it. And in fact, just imagine that this telescope is so awesome, it can even give us a retrospective history of the planets and stars and stuff. And so we now are very confident, or we could even say that we know that Earth is the only planet that's ever had life on it in the entire universe up till this point. What would you make of that? Would you find that to be really surprising or not?
Well, no, well, I already kind of suspect that there's a multiverse of all possible structures out there, and like that, basically anything that can exist does exist.
Okay.
So on those assumptions, then it wouldn't be terribly surprising to find that Earth is unique, because even if life is very rare, we're going to exist somewhere in the multiverse, and that's where we'll find ourselves. I guess it would be surprising if I could figure out that the typical observer would not expect to be on such a unique planet. Like maybe
Yeah, what if
if you're yeah, go ahead.
Yeah, what if, like, given what we know about the laws of physics, we should actually expect, like, we could do some kind of Drake equation thing, and like your typical calculation, given the condition, like we know what the universe is like and what the laws of physics entail. We know about how abiogenic processes work, and there's actually like 17 different ways to get life started on a planet and all this stuff. And so a model, given the conditions of our universe,
Okay,
says, yeah, about 10,000 planets with life per galaxy. And then we observe our universe, and we're the only one. At
I'm gonna
that
have to
point,
go in a
that's
minute, but
surprising by definition, right?
I'm gonna have to go in a minute, I think. But I think I have
Oh, okay.
an interesting answer for you on that one. Have you heard of Robin Hansen's grabby aliens
Yeah.
hypothesis?
Hmm.
So I think that might be evidence for Robin Hansen's grabby aliens hypothesis. Because just for anyone who doesn't know, the grabby aliens hypothesis is an attempt to explain the Fermi paradox, or
Hmm.
by saying that we don't see anyone around us, because if there had been other civilizations around us, one of them would have already consumed all the resources of Earth, and we never would have found ourselves here in the first place. That basically, when civilizations get advanced enough, they can expand their influence at almost the speed of light, and so the only observers who, like, you'll only ever find civilizations seeing themselves more or less alone, because if they weren't alone, they would have been gobbled up already, or their resources would have been gobbled up. So if we made those hypothetical observations, it might cause me to think that Robin Hansen must be onto something.
That's fair. I also want to say those kind of considerations do make sense to me, and I can reason in those terms. And I think as this conversation has progressed, you kind of greased the rusty parts of my brain for considering counterfactual situations. So I think if we have enough conversations, I'll have more responses and intuitions to these sorts of things instead of just going, I don't have a position. So yeah, like when you're laying that out, I'm like, yeah, that would make sense. That as soon as you said Robin Hanson, I was like, oh, I know where you're going with this, and that
Yeah,
makes sense. So
yeah.
yeah, cool. But you said you have to
Um,
get going.
I think I heard my wife's voice outside suggesting that we need to get going, so we might need to wrap this up. But it's been good. I've enjoyed this a
Yeah,
lot.
this has
Thanks,
been
man.
great. I didn't get to ask a bunch of questions about like the whole process of getting published outside of academia. So if you're up for it, let's do another conversation where we talk about, even if it's relatively short. I
Yeah,
like
yeah.
to give my audience an insight into that, because I am a big fan of people operating outside our academic institutions, because I think that they have. I think that there's a certain degree of insularity and gatekeeping and other sorts of problems that prevent potentially outside views from making a difference in those fields. So I'm like a big fan of the fact that you've done this and that you've put the effort into doing it. So it's something, to me, I would be very, it would be very important to me to talk about that.
Thanks very much, Lance, and thanks for all the time you've given me on Substack and other platforms where you've had long discussions and debates. It's been very encouraging to be taken seriously by someone like yourself, and Philip as well. Thanks very much, Philip. I know you're listening in. Philip's been a great support and encouragement to me as well in trying to publish something. So, and various other people we could mention, like Keith Frankish and Pete Mandic as well, and Quentin Rionk gave me a lot of time too. Anyway, we might have to leave it there. Thanks very much, Dan.
Let's leave it there. Yeah, I do want to say, Philip and a lot of other people, I really like people in this community that prop one another up and encourage people to spread their ideas even when they disagree. And I think Philip in particular has been very good at cultivating an atmosphere of collegiality and acceptance for opposing views, when often people are kind of contemptuous or hostile towards people with opposing views. And I really don't like that attitude. And I like Philip's attitude. So it's great to see people succeeding and producing things because of that positive atmosphere. So yeah, I'll leave it there. Final word from you, and then we'll close things out.
No, just to say thanks again, and it's been fun, and I'd love to do it again sometime.
All right, let's do it. Thanks everybody for being here. I know we didn't interact with the audience too much, but you know, there'll be more opportunities for that. So like the video, subscribe, check the description. There'll be a link to your paper in there. I'll link the Substack as well, and we'll call it there. Thanks again for being here. Take care, everybody.
Thanks. Bye.